Okay, as I've said in the past, not through any fault of yours, the curriculum that we have to offer has changed, and therefore this now is what Year 9 mathematics should be doing. Okay, my fear was if we went straight into what is known as distributive laws, there are 5. If we went straight into distributive laws, many of you would have found it very difficult. Okay, so I'm hopeful that what we've done in the previous 4 weeks, 2 weeks of this term, about 2 weeks of last term, has got you in good stead for this stuff. Now, with distributive laws, there are 5 of them that we'll go through. With any rules or laws, all you have to do is memorise them. Once you memorise what they are, the only ones that have trouble with these distributive laws are those that don't take the time to remember them. Okay? So we're going to go through the first one today, and the beauty of what we've done in the previous 4 weeks is it starts to use language you've heard now before. I know you've heard it because I introduced it to you. So with distributive law 1, with expressions such as these, you've heard me say the phrase, everything outside the brackets affects that which is inside the brackets. So if we look at this, everything outside the brackets affects that which is inside, which is the x and the plus 3. Okay? Taylor, what do we have between the start of the brackets and the 4? What sign? A multiply sign, a times sign. Okay, so we're saying this would be 4 times the x, add 4 times the plus 3. Okay, so that's virtually the easiest distributive law of all, is the first one, but we'll look at that a little later. You've had plenty of laws in your past about mathematics. If you just have a look at this first one, A, okay, 2 times 5 plus 3, what rule is being used there, Harry, in order to get 2 times 8? What rule or law that you've learnt about in your past? Any idea? No? Connor?
Everything inside the brackets is affected from outside the brackets?
No, not quite. We're not using that just here. Jake? Yeah, so what rule or law is that? Bedmass, yeah, bedmass, that's right. Okay, so the rule we're using there is the rule of bedmass, brackets, exponents, division, multiplication, addition, subtraction. And I reckon you would have done that in year 8, year 7, but we certainly did that at the start of this year. And that's what we're doing there. 2 times brackets 5 plus 3, well, we do this first, brackets. 5 plus 3 gives us 8, 2 times 8 gives us 16. What about with this process? 2 times 5 plus 2 times 3. What rule are we using there? What rule are we using there?
Bedmass, but because you follow that still.
Yeah, and so why are we using bedmass, Woody? That's right.
Because with that, the multiplication goes before the addition.
Good. It's the multiplication which happens before the addition, so it's the multiplication of this and the multiplication of this before we do the addition. 5 times 2 is 10, 2 times 3 is 6, 10 plus 6 gives us 16. What do you notice? We get the same answer to these problems. Okay, just on that scrap bit of paper that I asked you to get organised to start with, can you just do A to F, please? Just on a scrap bit of paper. It doesn't have to be overly neat. Okay, I'll do the first one for us together. Obviously, we're using bedmass. All right, so we're thinking about this first. I'll give you a couple of minutes on that. Okay, so a bit of time to have done that. Let's go through the answers. So we're using bedmass to start with. Okay. Beth, can you do A for us, please?
Add the 1 and 4, which is 5, and 7 times 5 is 3.
Excellent, well explained. Add the 1 to the 4, which gives us this, and then times the 7 by 5, which is 35. This is all very simple, particularly for blue group. For some of you, this will be very simple, but it does get more difficult when we chuck in the unknowns, the coefficients, the x's, the y's, okay? And the key to the next one, please.
7 times 1 plus 7 times 4 is 7 plus 28, which is 35.
Equals 35. Good. This one, Connor.
Add the 2 and 8, which is 10. And
Yes.
6.
Give us 16. Next one, we do the multiplication first. 6 times 2 is 12, plus 6 eighths are 48.
You've done the first one wrong.
I've done the first one wrong. Absolutely. Thank you, Woody. Oops. Wish I couldn't guess that. I can't.
Math class was over.
Should have been times in there, shouldn't it?
No, you've done 6 times 1 instead of 6 times 2. Oh wait. Yeah, it should be times, yeah.
Being 60. This one, 12 plus 48 equals 60. And Sean, this one? Yep. So what would we do first?
I don't know. I didn't.
We'd do the brackets first. So what's the
Yeah.
brackets?
3 plus 4, which is 7.
Good. 5 times 7.
5 times 7 is 35. Yeah,
Good.
35.
Yep. And this one, 5 times 3 is 15, plus 20 gives us 35. What do we notice about all answers there? A and B, C and D, E and F. Georgie, what's a common theme that's happening there?
They equal the same thing.
They equal the same thing. Yes, that's right. And can you start to see the distributive law there? Where we're saying if we think this in our head, 7 times 1 plus 7 times 4, we're doing the 7 times 1 plus the 7 times the 4. So if we were to scroll down on this page, you can see, hopefully, that distributive law there. Okay, so distributive law 1. Whoa. Don't like the look of that. Distributive law 1 has these arrows. Now, students I've taught in the past, those that are most successful of it actually do these arrows in their book. So all I'm saying, I'm encouraging you to use arrows in your learning, all right? They won't always be easy as A times B plus A times C, which is what you get there. A times B plus A times C. Everything outside the brackets is multiplied by that which is inside. Remember, there's a multiplication sign there. Okay? Over time, there could be 15 or 16 different things here, and you've got to collect the like terms on the other side of the equal sign. So my encouragement to you is in the early stages, use those arrows just to remind you of what you've done and what you haven't. Can you go to your glossary now, please, and can you draw in or write in, please, distributive law 1? Remember that there's going to be 5 of them. So in your glossary, if you can just write them down, please. That first one, that's the one we're working with today. Some of you won't understand this explanation that I'm about to go through. That's all right. You don't necessarily need to. But I do know that sometimes this helps some of you, okay? So there is a geometric demonstration of what you're doing here, and it involves rectangles. If we had 2 rectangles here, rectangle 1, rectangle 2, and their measurements are A by B and A by C, okay, the area of the large rectangle therefore is A brackets B plus C. Because what you're doing is you're multiplying the A by the B and the A by the C. rectangle 1 has A by B, and added to that for the total area, you're adding A times C. Some of you will understand it better using that way. Some of you will just go, who cares? That's okay. All right. So that might help some of you. It may not. Let's have a look at some examples. So these are more realistic to what we had prior above. Again, use the arrows here. So we've got 3 times 4x plus 3 times 1. Okay, 3 times 4x plus 3 times 1. 3 times 4 is 12x plus 3 times 1 is just 3. And these are quite easy when we've got plus, plus, and plus. Okay, where they become a little bit more difficult is where we're about to go. Okay, which are these ones. Again, we're using language that we've used in the previous topic. The sign belongs to that which comes after it. All right, so this is negative 2x. This is negative 2x, and this is negative 3. So remember that sign belongs to that which comes after. What we're doing here, what's the first step we would do in part B here, Jeremy?
Do the brackets.
No, because we're not using BEDMAS rule now. We're using the distributive law rule. Okay. Yep. What would be the first thing, mate? Good try.
Times 2x by 5.
Awesome. 2x times 5, and I put the arrow in. I personally do because it helps me remember what I've done. And I'd write it 2x times 5. Okay, which is there. And then the next thing that we'd do, Kayla, times 2x by negative 2x, good girl, times 2x times 2x, the positive 2x, by negative 2x. Hopefully in your glossaries, which I've just asked you to turn to, there's all the positive and negative rules as well. All right? Because these come in handy now. 2x times 5x, well 2 times 5 is 10x. So we've got that sorted, 10x. And then this one is a positive and a negative, must become a negative. 2 times 2 is 4. X times x is x squared. So I'm hoping what you're saying is some similarities between what we've just been doing. Alright, I see some nods. This last one, negative 2x, what's the first thing we should do there, Monique?
I don't know.
No, don't panic, don't be a kangaroo in the headlights. What's the first thing we do with the distributive law? Think of the arrows.
Oh, we add 2 to... I don't know.
Okay, we'll keep listening. Okay, Beth?
Negative 2x times x.
Negative 2x times x. So Monique, the first thing we do is this.
Oh,
Okay? Negative 2x times the x. Alright, negative 2x times the x. Negative and a positive gives us a negative. 2 times, what's here, Sean?
X.
How many?
2. No.
How many here?
1.
1, because we don't write it, do we? We don't write it in, but it is just 1 when there's that. 2 times 1 is 2. X times x is x squared. Alright? So we've done this. Okay, the next step therefore, I'm going to go back to you, Monique. What's the next step now?
You have to separate them and then do each separate sum away. Then find the answers.
So we've done this. What's the next step? What do we have to do?
It's 2x something, and then we go to 3.
Yeah, you're getting there. Yep, Taylor, can you just sort that language out a bit?
Negative 2x times 3.
Negative 2x times.
Negative 3.
Excellent. Negative 2x times negative 3, because it's all of this. Negative 2x times negative 3. Negative and a negative is a positive. 2 times 3 is 6, and we've got x. So we're left with that. Okay? Are there any questions? You want me to go through some to clarify? Speak up now.
Can you scroll down a bit?
Yep.